NEC 334.15. B permits running non-metallic sheath cable, often referred to as NM cable, in unfinished attics and roof spaces without the need for conduit. Additionally, NEC 334.10 allows NM cable to be used in concealed spaces. These concealed spaces include areas such as walls, spaces above suspended ceilings, and, again, unfinished attics and roof spaces. However, there is a specific requirement when the cable is run through bored holes in joists or studs. In such cases, the cable must be protected with a grommet or an equivalent protective device. Therefore, based on the National Electrical Code, conduit is generally not required for running NM cable in an unfinished attic or similar concealed space, provided it's not subject to physical damage. The key is ensuring that the cable is adequately protected where it passes through any structural members. When installing electrical circuits, it is crucial to adhere to the National Electrical Code, or NEC, for safety and compliance. The NEC provides guidelines and regulations for various wiring methods, including the use of non-metallic sheath cable, commonly known as NM cable or grommets. NM cable is widely used in residential wiring due to its ease of installation and cost-effectiveness. However, it's essential to understand the specific requirements for its installation in different locations, such as attics and concealed spaces. Article 334 of the NEC covers the requirements for NM cable. As mentioned earlier, NEC 334.15. B specifically addresses the installation of NM cable in unfinished attics and roof spaces. This section states that NM cable can be run without conduit in these areas, provided it meets certain conditions. The primary condition is that the cable must be protected from physical damage. In an unfinished attic, this typically means ensuring that the cable is not exposed to potential impacts or abrasions. This can be achieved by running the cable along the sides of joists or rafters, or by securing it to running boards. Furthermore, NEC 334.10 expands on the permissible uses of NM cable. It allows NM cable to be used in concealed spaces, which are defined as areas that are not readily accessible after the building is finished. This includes spaces within walls, above suspended ceilings, and, as previously noted, unfinished attics and roof spaces. The allowance for NM cable in concealed spaces is based on the assumption that the cable is protected from physical damage within these spaces. However, there is a critical exception to the general rule regarding the use of NM cable in attics and concealed spaces. This exception applies when the cable is run through bored holes in joists or studs. In these cases, the NEC requires that the cable be protected with a grommet or an equivalent protective device. A grommet is a small, typically rubber or plastic, fitting that is inserted into the bored hole. The cable is then run through the grommet, which provides a smooth, protective surface that prevents the cable from rubbing against the sharp edges of the hole. This protection is essential to prevent damage to the cable's insulation, which could lead to short circuits or other electrical hazards. The requirement for grommets in bored holes is based on the potential for the cable to be damaged over time due to vibration or movement of the building. Even if the cable appears to be securely fastened at the time of installation, it can gradually shift and rub against the edges of the hole, eventually wearing away the insulation. By using a grommet, you create a barrier that prevents this type of damage. When selecting grommets, it's important to choose ones that are specifically designed for electrical wiring. These grommets are typically made of materials that are resistant to heat and chemicals, and they are designed to fit snugly in the bored hole. It's also important to ensure that the grommet is properly sized for the cable being used. A grommet that is too small can pinch the cable and damage the insulation, while a grommet that is too large may not provide adequate protection. In addition to grommets, there are other equivalent protective devices that can be used to protect NM cable in bored holes. These include plastic bushings, cable clamps, and even short lengths of conduit. The key is to choose a device that provides a smooth, protective surface for the cable to pass through. When installing NM cable in an attic or concealed space, it's also important to consider the potential for the cable to be exposed to extreme temperatures. Attics, in particular, can become very hot in the summer and very cold in the winter. These temperature extremes can affect the insulation of the cable, potentially leading to premature failure. To mitigate this risk, it's recommended to use NM cable that is rated for high temperatures. These cables are typically marked with a temperature rating of 90 degrees Celsius or 194 degrees Fahrenheit. It's also important to avoid running NM cable near heat sources such as chimneys or exhaust vents. Another important consideration when installing NM cable is the proper support and fastening of the cable. The NEC requires that NM cable be supported at intervals of not more than 4.5 feet and within 12 inches of every box or fitting. This support can be provided by staples, cable ties, or other approved methods. The purpose of this requirement is to prevent the cable from sagging or being subjected to excessive strain, which could damage the insulation or the conductors. When stapling NM cable, it's important to use staples that are specifically designed for this purpose. These staples have a rounded head that prevents them from cutting into the cable's insulation. It's also important to avoid overdriving the staples, as this can also damage the insulation. In addition to the general requirements for installing NM cable, there are also some specific requirements that apply to kitchen circuits. Kitchens are considered to be high-demand areas, and the NEC requires that they have a minimum number of branch circuits to accommodate the various appliances and equipment that are typically used in kitchens. The NEC requires that kitchens have at least two 20-amp small appliance branch circuits. These circuits are specifically intended for supplying power to countertop appliances such as toasters, coffee makers, and blenders. The purpose of this requirement is to prevent overloading of the circuits, which could lead to trip breakers or even electrical fires. In addition to the small appliance branch circuits, the NEC also requires that kitchens have at least one 20-amp individual branch circuit for the refrigerator. This circuit is specifically intended for supplying power to the refrigerator, and it should not be used to power any other appliances or equipment. The purpose of this requirement is to ensure that the refrigerator has a dedicated power supply, which is essential for maintaining its proper operation. When installing kitchen circuits, it's important to use the correct size wire for the amperage of the circuit. For a 20-amp circuit, the NEC typically requires the use of 12-gauge wire. However, if the circuit is run over a long distance, it may be necessary to use a larger size wire to compensate for voltage drop. Voltage drop is the reduction in voltage that occurs as electricity flows through a wire. The longer the wire, the greater the voltage drop. If the voltage drop is too high, it can cause appliances to operate inefficiently or even fail. To calculate voltage drop, you can use a voltage drop calculator or consult with a qualified electrician. In the specific scenario described, where the cable run is approximately 90 feet, it may be necessary to use 10-gauge wire for the 20-amp circuits. This is because the longer distance can result in a significant voltage drop if 12-gauge wire is used. By using 10-gauge wire, you can reduce the voltage drop and ensure that the appliances operate properly. In addition to the wire size, it's also important to choose the correct type of NM cable for the application. NM cable is available in several different types, each with its own specific properties and uses. The most common type of NM cable is NMB, which is suitable for general-purpose wiring in dry locations. However, if the cable is to be installed in a damp or wet location, such as a basement or garage, it's necessary to use a different type of NM cable, such as UFB, which is designed for use in these environments. When installing electrical circuits, it's also important to follow all of the applicable safety precautions. This includes turning off the power to the circuit before working on it, using insulated tools, and wearing appropriate personal protective equipment such as safety glasses and gloves. It's also important to have a working smoke detector and carbon monoxide detector in the area where you are working. If you are not comfortable working with electricity, it's best to hire a qualified electrician to do the work for you. The electricity can be dangerous, and it's important to take all of the necessary precautions to protect yourself and your property. In summary, when installing 20-amp kitchen circuits, it is generally not necessary to use conduit in an unfinished attic, provided that the NM cable is protected from physical damage and is run in accordance with the NEC. However, it is essential to use grommets or equivalent protective devices where the cable passes through bored holes in joists or studs. It is also important to use the correct size wire for the amperage of the circuit and the length of the run, and to follow all of the applicable safety precautions. By following these guidelines, you can ensure that your kitchen circuits are installed safely and correctly. Additionally, it's worth noting that local codes and regulations may vary from the NEC. Therefore, it's always a good idea to check with your local building department to ensure that you are complying with all of the applicable requirements. They can provide you with information on any specific local amendments to the NEC, as well as any other relevant regulations that may apply to your project. Furthermore, it is important to consider the long-term maintenance of the electrical system. Properly installed and maintained electrical systems can last for many years, providing reliable service and safety. However, neglecting maintenance can lead to problems such as loose connections, damaged wiring, and overloaded circuits. To ensure the long-term reliability of your electrical system, it's recommended to have it inspected periodically by a qualified electrician. They can identify any potential problems and make recommendations for repairs or upgrades. This is particularly important in older homes, where the electrical system may be outdated or may not meet current safety standards. In addition to regular inspections, it's also important to be aware of any signs of electrical problems such as flickering lights, tripped breakers, or warm outlets. If you notice any of these signs, it's important to investigate the problem and take appropriate action. This may involve replacing a faulty component, tightening a loose connection, or upgrading the circuit to handle a higher load. Finally, it's important to remember that electrical work can be dangerous, and it's always best to err on the side of caution. If you are not comfortable working with electricity, or if you are unsure about any aspect of the installation, it's best to hire a qualified electrician to do the work for you. They have the knowledge, skills, and experience to ensure that the job is done safely and correctly. By following these guidelines, you can ensure that your electrical system is safe, reliable, and compliant with all of the applicable codes and regulations. The National Electrical Code is a comprehensive set of standards that covers all aspects of electrical installations. It is updated every 3 years to reflect the latest technological advancements and safety practices. The NEC is developed by the National Fire Protection Association, or NFPA, and it is widely adopted by jurisdictions throughout the United States. While the NEC provides a comprehensive set of standards, it is not a substitute for good workmanship and common sense. It is important to follow all of the manufacturer's instructions for the electrical equipment that you are installing, and to use good judgment when making decisions about the installation. If you are ever unsure about anything, it's always best to consult with a qualified electrician. They can provide you with expert advice and guidance, and they can help you to ensure that your electrical system is installed safely and correctly. By following these guidelines, you can create a safe and reliable electrical system that will serve you well for many years to come. And remember, electrical safety is not just a one-time event. It is an ongoing process that requires vigilance and attention to detail. By staying informed and taking the necessary precautions, you can protect yourself, your family, and your property from the hazards of electricity. Finally, it's worth mentioning that there are many resources available to help you learn more about electrical safety and the National Electrical Code. These resources include books, websites, online courses, and training programs. By taking advantage of these resources, you can expand your knowledge and improve your skills, and you can become a more informed and responsible electrical consumer.